Welcome to the DIY Honda Garage channel. The Diagnostic Trouble Code DTC P0715 indicates a malfunction in the input shaft or main shaft speed sensor circuit for the Honda Civic models from 2016 to 2021. This sensor plays a crucial role in the vehicle's transmission system by measuring the speed of the input shaft, which is essential for optimal engine and transmission performance. It communicates this information to the Powertrain Control Module, PCM, which then makes necessary adjustments in real time to ensure smooth operation. If there's a circuit malfunction, the vehicle may exhibit performance issues, such as delayed shifting or poor acceleration. The sensor itself is typically located near the transmission housing, where the input shaft enters, making it crucial for any transmission-related diagnostics. Addressing DTC P0715 is vital to restore proper function and prevent potential long-term damage to the vehicle's transmission system. DTC P0715 specifically refers to a malfunction in the input shaft speed sensor circuit, which directly affects the vehicle's transmission behavior. The input shaft speed sensor is invaluable as it monitors the rotational speed of the main shaft, assisting the PCM in making real-time adjustments to transmission shifting. Located at the transmission housing, this sensor ensures the engine operates efficiently and smoothly integrates with the automated transmission system. If the input speed data is incorrect or missing, it disrupts the shifting process, potentially leading to poor vehicle performance. It is vital to understand that this sensor's failure could trigger various symptoms, highlighting the importance of its functionality. Addressing any issues with this component directly influences the vehicle's drivetrain performance. When diagnosing DTC P0715, several possible causes must be investigated. First, poor connections at the input shaft speed sensor, or the PCM, can lead to intermittent failures, resulting in unreliable readings. Loose terminals can also interrupt the flow of data, compromising the sensor's ability to communicate effectively. Additionally, a direct malfunction of the input shaft speed sensor itself may occur, either due to wear and tear or environmental factors. Lastly, wiring issues such as open circuits or shorted wires are critical points to check, as they can severely affect the integrity of the sensor's signal. Each of these aspects needs careful consideration during the troubleshooting process to find the root cause of the malfunction. Drivers experiencing DTC P0715 may notice multiple symptoms related to the vehicle's transmission performance. Delayed shifting is a common issue, where the vehicle hesitates to change gears, leading to uncomfortable driving experiences. Poor acceleration can also be a significant indicator. The vehicle may struggle to gain speed or respond sluggishly when pressing the gas pedal. Furthermore, unusual transmission behavior, such as erratic shifts or the transmission seemingly hunting for the correct gear, may present itself. Moreover, the engine may experience increased load, causing premature wear and potentially leading to more severe mechanical failures. These symptoms can impact overall driving comfort and vehicle efficiency, making it imperative to address the DTC P0715 promptly. The first step in troubleshooting DTC P0715 involves verifying the problem through specific engine tests. Begin by starting the engine and allowing it to warm up. Once started, hold the engine speed at approximately 3,000 RPM without load, ensuring it is in neutral until the radiator fan activates. This test allows the system to stabilize and present accurate parameters for examination. After this, conduct a test drive at a steady speed of 9 miles per hour or 15 kilometers per hour for several minutes to assess the operation of the input shaft speed sensor. During this process, utilize the Honda Diagnostic System, HDS, to check the main shaft speed values, confirming whether the system is indicating a speed. If the mainshaft speed is present and readings appear stable, the failure might be intermittent, indicating potential wiring issues or connectors that need further inspection. Step 2 involves determining the potential failure area by checking the sensor's electrical connections. Start by turning the vehicle to the off position, ensuring all systems are inactive. Next, disconnect the input shaft speed sensor 3P connector. Once disconnected, switch the vehicle to on mode to activate the electrical system while keeping the sensor disconnected. With the HDS, measure the voltage between test points on the sensor connector. Specifically, you should measure between the female terminals number 1 and number 3. An appropriate reading of around 5.0 volts will indicate that the VCC2, voltage common collector 2, line is functioning correctly. A different voltage reading will necessitate further investigation into the wiring to locate faults in the voltage supply or ground connections. In the third troubleshooting step, the focus shifts to checking for any open wiring issues along the VCC2 line. Keeping the input shaft speed sensor 3P connector disconnected, measure the voltage once again between the sensor's terminal female number 3 and body ground. This measurement aims to confirm the integrity of the VCC2 line. A reading of about 5.0 volts indicates that the line is functional. If the voltage is absent, it denotes an open wire condition in the VCC2 line. Addressing any detected faults requires repair on the open wire, particularly focusing on connections from the PCM terminal number 83 to the sensor. Ensuring secure and uninterrupted power supply is essential for optimal operation of the input shaft speed sensor. For the fourth step in troubleshooting, it is essential to check for shorted wires within the NM line. Begin by turning the vehicle to the off, lock mode, and then use the HDS to jump the SCS, service check switch line, maintaining this state for more than 1 minute. Afterward, disconnect the PCM connector number 1, 96P, to isolate the circuit for testing. The next action involves checking for continuity between the PCM connector terminal number 69 and body ground, while ensuring the input shaft speed sensor connector remains disconnected. If continuity is found, it implies a short may exist in the NM line, warranting immediate repairs. Such an identification aids in addressing discrepancies in the sensor signals resulting from damaged wiring channels. The fifth step requires a continuity check for the NM line with a focus on confirming the integrity of the wiring connections. The input shaft speed sensor 3P connector and the PCM connector number 1, 96P, both need to remain disconnected. Measure continuity between the input shaft speed sensor's female terminal number 2 and the PCM connector number 1, terminal number 69. The objective is to ensure a continuous electrical path, confirming no breaks in wiring exist. If continuity is present, proceed to the next step. Otherwise, repair any detected open circuits in the NM wire. Undertaking this step ensures the reliable transmission of sensor data to the PCM, maintaining proper vehicle operation. Step 6 involves replacing the input shaft main shaft speed sensor with a known good unit to evaluate if the current sensor is defective. Begin by reconnecting all previously disconnected connectors to ensure the sensor can communicate effectively with the PCM. After ensuring connections are secure, utilize the HDS to clear any existing DTC codes from the system. Following this, start the engine and once again hold it at 3,000 RPM without load, testing for the operational integrity of the transmission. Finally, conduct a test drive at a steady speed of 9 miles per hour or 15 kilometers per hour for several minutes before checking for any confirmed or pending DTCs using the HDS. If DTC P0715 remains indicated, further investigation into the PCM may be necessary. Conversely, resolution suggests the original input shaft speed sensor was faulty. After completing the troubleshooting and repair process for DTC P0715, it's crucial to verify that all repairs are successful and that the issue has been resolved. The first step in this verification is to ensure no DTCs reoccur during the diagnostic check using the HDS after clearing the codes. Conducting a thorough test drive allows for real-world validation of the repairs, ensuring the vehicle operates correctly at various speeds and under different driving conditions. This step helps to confirm that the input shaft speed sensor is functioning effectively and relaying the correct information to the PCM. Documenting the results of the repairs, including any codes that were cleared and any symptoms observed, will be beneficial for future reference and underscores responsible vehicle maintenance. Preventive maintenance is essential in keeping the input shaft main shaft speed sensor and its associated circuitry functioning optimally for the Honda Civic. A thorough and regular inspection of the wiring harness can prevent potential issues before they develop into serious faults. Check connector conditions to ensure they remain free of corrosion or loose connections, as these can lead to data transmission problems. Additionally, regularly monitoring the performance of the input shaft speed sensor can highlight early signs of wear or malfunction. Addressing any issues promptly can help avoid larger, more costly repairs down the line. Preventive actions, when implemented consistently, enhance vehicle reliability and operational safety. In summary, DTC P0715 indicates a malfunction within the input shaft speed sensor circuit, impacting the vehicle's transmission performance. Following the structured troubleshooting steps outlined ensures a comprehensive approach to identifying and resolving the root cause of the issue. Confirming the functionality of the input shaft speed sensor through proper testing is critical in restoring effective vehicle operation. Maintaining wiring and connectors is equally important, as these components significantly influence sensor performance. Lastly, adopting preventive measures and regular maintenance can help avoid potential sensor issues in the future. Overall, a proactive approach to diagnostics and repair ensures sustained performance and reliability for the Honda Civic. Please like and subscribe to the channel. See you next time.